All right, so first section we did was section 1.1. It's the only section we do in chapter 1. Now we just basically jump right into chapter 2. We're going to spend Tuesday, Wednesday, and Thursday on section 2.1. Today we're going to look at basically how we can change between two different ways of measuring an angle. One way is degrees, but there's another way. It's kind of like feet and inches. It's a different way of measuring. Tomorrow we're going to look at a couple formulas in this section. And then the last day we're going to look at how we can calculate the speed of like an object spinning. That's like RPMs, like how many revolutions per minute, stuff like that. Right. So we'll be using degrees and the other unit I'm going to teach you throughout all those lessons. So first of all, degrees and radians, the most common thing we do with them is we measure angles. So I'm going to start by just defining what an angle is, and even more basic, what are the parts that make up an angle. And the first thing, if we're going to talk about an angle, is a ray. So a ray is basically just a line that only goes in one direction. Okay, it's a portion of a line, and it starts at one point, goes forever in one direction, and where it starts is called the vertex. So the idea is if we take two rays and put them together, then we've created an angle. The key is when you put the two rays together, they have to have the same vertex. Right? So if you had a ray like that, and another one like that, if you want to create an angle out of those two rays, just put the two vertices on the same spot, and you just created an angle. And there's another picture as well. So technically, when you put the rays together like that, you just created two angles. There's one on the inside, and then there's another one on the outside. Most of the time, unless the directions say otherwise, we're talking about the one on the inside. Okay, the one that's between the two rays. So it's, by between, I mean the one that's smaller than 180. Okay, where I put that mark. Okay, any questions on that idea? So that's an angle, if you want to draw an angle all by itself. Now, technically, if you've got a shape like this, and you say, well, what about this right here? Isn't that an angle? Yeah, that's still an angle, even though these aren't rays. These are line segments. So usually when you draw a shape, an angle is between two line segments. When you draw an angle all by itself, you usually use two rays. Okay? Both of those things are considered angles. Just one's in a shape, one's all by itself. So the angle has two sides. It has what we call an initial and a terminal side. Okay, and I'm going to show you kind of an easy way how to tell which way is which. But in that diagram I have up above for the angle, this would be the initial. This is the terminal. Basically, it has to do with rotating counterclockwise from one side to the other. Kind of like that. Where you start is the initial side. Here's another diagram of the same thing. Where you end is the terminal side. Okay. So to figure out which side is initial and terminal, go between the two rays, and then go counterclockwise, and wherever you end up stopping, that's the terminal side. So if you had an angle like this, if I go between the two rays and go in a counterclockwise direction, initial is over here, terminal would be where I end up. Now, I specifically said counterclockwise because when you move between two rays, you have a choice. You could go inside, go counterclockwise, or you could go outside. Okay? Well, whether we go inside or whether we go clockwise or counterclockwise basically controls whether or not you're looking at a positive or a negative angle. All right, so if you measure an angle going from the initial to the terminal side in a counterclockwise direction, that's a positive angle. All right, so if you go in the counterclockwise direction, it's a positive angle. What do you think happens if you go in the clockwise direction?
Negative.
Yeah. Okay. If you go in the clockwise direction, it's a negative angle. If we had a choice of working with angles, which kind of angle do you think we generally prefer? Positive or negative? Yeah, if we can, positive angles are just kind of easier to visualize and think about. Like if I said 90-degree angle, most people can visualize that in their head. If I said negative 270, it technically is the same thing, but most people don't think of that one as quick as they do 90. I'll show you that 90 and negative 270 are the same thing right now. Okay, so what I have here is basically a program where I can move the terminal side. I can't move the initial. Okay, that's always going to be right on the positive x-axis. But if I go counterclockwise, like I am now, I'm making a positive angle. It's measuring it in degrees in the top, and it's using a different number in the bottom. That's the other number we're going to study later. Does anyone know what that other number is? 5.29? And that is exactly how you write it. You don't even put a label after it. If it's degrees, you got to put the little circle. But if it's this other unit, you don't have to put anything. You just leave it like that. Anybody know what the 5.29 is? All right, we'll talk about it later. For now, I just want you to see positive and negative. So there's positive. If I go more than one revolution, then I just get an angle that's more than 360. And you can kind of tell by the spiral. All right, so let's put it back at 0. And now if I go negative, I'm going in a clockwise direction. I get a negative angle. Now I said to you that 90 and negative 270 look exactly the same in terms of where the initial and terminal sides are. Here's 90. Okay. It's a right angle. Well, let's see if I can get it to stop. Right there. So the initial side is on the positive x-axis. Terminal side is on the positive y-axis. Now look at negative 270. You get the idea. The initial and terminal sides are in the exact same spot. So when we're doing trig, whether we use positive 90 or negative 270, those two numbers mean exactly the same thing when we're talking about angles in trig. Okay. And as far as what that bottom number is, we're going to talk about that later. Now, in that program, all I could do was move the terminal side. I can't move the actual angle, like I can't take and slide it over, to the left or the right. I also can't move the terminal side. So every angle that I just drew, okay, all of these, like this, like that, all of these angles are what we call standard position. Okay, when you draw an angle in standard position, two things has to happen. Okay, first thing is that the vertex of the angle is always at the origin. The second thing that has to happen is the initial side is always on the positive x-axis. That's exactly how every angle I just drew in that program looked. Okay, so here's another picture of an angle in standard position. It meets both criteria. Vertex at the origin? Yep. Initial side on the positive x-axis? Yep. How about if I did that? Is that angle in standard position? What do you think? How about Kareem? Yeah, what do you think?
The vertex isn't at the origin.
No, vertex isn't at the origin. That's not standard position. How about if I did something like that? Is that standard position? No, why not?
Because it's on the positive x-axis?
Yeah, the initial side, which is right here, is supposed to be on the positive x-axis. In this case, the terminal side is on the positive y-axis, but the definition says nothing about the terminal side. It says initial side should be on the positive x-axis. So that's standard position. All right? What that basically does for us is if I ask you to sketch a 45-degree angle, everybody's angle should pretty much look the same. It's not like people would have an angle turned funny and stuff like that. Everybody's would look like that if it's in standard position. Any questions on that? All right, so I mentioned to you that negative 90 and positive 270 are the same angle. There's a special name for that. I don't think I'm going to go through it right now, but eventually I'll tell you what that's called. There's a special name. All right, so that other number that I was asking you about, I said, does anybody know what it is? It was what's called a radian. So degrees versus radians, it's two different ways to measure an angle. The more common way is radians. When you get into like higher level math, like calculus, things like that, they never use degrees. Ever. They just don't use it anymore. And if you look at the word radians, does anybody see like another word that kind of looks like the word radian? Has some letters, a lot of letters in common. Yeah.
I mean, it reminds me of ratio.
Ratio? All right, so I can see with the RA there, it's the same. I'm thinking of a word that's got even more letters in common. Yep.
Radical.
Radical. That's a good one actually, but because it has a lot of letters in common, but not radical. That is a good one. Yeah.
Radius.
Radius. Yeah. This radian and radius, they have the same four letters, so it's radical, but that's a little different. And a radian has a lot to do with a radius. And where do you find a radius? Like radius, yeah, it comes up in a circle, so we're going to look at some stuff with circles. The goal by the end of today is to figure out that question mark. If we can figure out how many radians in 360 degrees, then we can convert between degrees and radians. We just need to know a connection between the two. It's kind of like if I gave you this equation and I said 12 feet. Or actually, let's do it this way. 1 inch. That's better. No, 12 inches. I don't know math. 12 inches equals. And I said how many feet? So how many feet in 12 inches? 1. So what you have now is you've got a connection between inches and feet. That's always true. There's always 12 inches in 1 foot. So now, if I said, well, what about 8 feet? How many inches? All you'd have to do is set up a proportion where you set it up exactly the same way on the left and on the right, and you start with the fact you know. In 12 inches, there's 1 foot, and then type in what you don't know. If you said, I don't remember what I said, how many inches in 8 feet? So how many inches in 8 feet? And now you could cross multiply and solve. But the key is you have to know this. You've got to have a fact to start with that gives you a connection between inches and feet. So we've got to figure out that question mark. All right, so we'll talk a little bit about what a radian is first, what it looks like, and then we'll see if we can somehow do a calculation to figure out that question mark. All right, so what I've drawn there is a circle. And I've put an angle inside the circle. The vertex, it's supposed to look like it's right at the center of the circle. And I labeled each ray of the angle as r, because it's the radius of the circle. Now, the two radii come out from the vertex, and they hit the edge of the circle here and here. Between those two green dots, I've traced part of the circumference, and that's called an arc. So that arc in red is the part of the circumference that we say is intersected by the angle, because the two rays of the angle, they hit the circumference there, they intersect it. Okay. Questions on that picture? Now, if you were to take a piece of string, right? Well, for the radius, you wouldn't need to. You just take a ruler and you measure that. And then let's say you take a piece of string, you put it on that arc in red, you get the length of the string, you straighten it out and measure it. If the length of this arc in red and the length of this radius come out exactly the same, then that means you have a picture of 1 radian. That's what it would look like. Still doesn't tell you how many degrees in a radian, it just kind of gives you something to visualize. So if the length of the arc in red is the same as the radius of the circle, the line in black, then you've just drawn an angle that is exactly 1 radian. And that picture's not perfectly to scale, but it's pretty close. That's about what the size of 1 radian would look like. But we got to do better than having a picture that's about the size. We actually got to get a number. Okay, we got to work on that. Now, if your picture had an arc that was bigger than the radius, then your angle would be bigger than 1 radian. If your picture looked like that and it had a really small arc, then your angle would be smaller than 1 radian. And when the arc is exactly the same as the radius, it's exactly 1 radian. So to figure out how many radians in a degree or how many degrees in a radian, we need to kind of know both. I got to give you something to start with. Okay? I got to kind of give you a fact that is true, and we can kind of go from there. So the fact that I'm going to give you is that it says an angle's measurement in radians is numerically equal to the length of the corresponding, I use the word intercepted, corresponding intercepted, same thing. The length of the corresponding arc on a unit circle. All right, so first thing we got to figure out, it says an angle's measurement in radians is equal to something else on a unit circle. So we just have to explain what that is. So all that a unit circle is, it's a circle, but it has a special radius. It has a radius that's a very easy number to work with. Does anyone have a guess what the radius would be in a unit circle? Well, if you had to think, like, if you could pick a circle to have any radius you wanted the radius to be a simple number. What could you pick the radius to be? So the radius is the simplest number you could have to work with. If you got to do arithmetic with it, it's an easy number. How about Taryn?
1.
Yeah, 1. Right? So a unit circle is a circle with pretty much the simplest radius you can have. It's a positive number. It's not a fraction. It's just a circle with a radius of 1. That's what it means. All right. So if we draw a circle that's exactly a radius of 1, and if you're thinking 1 what? It doesn't matter. 1 foot, 1 inch, 1 mile, just 1. Whatever you want to call it. So if we draw a circle with a radius of 1, let's do that. Here's a circle. And here's a radius of 1 unit. Now, let's draw an angle inside that circle. Let's Let's go like this. Now, if you measure that angle in radians, it says that it's going to be equal to the arc. Right? If you measure that angle in radians, whatever this comes out to right here, using your protractor, say it came out to like 2.6 radians. Well, if you took a piece of string and you measured that, that would come out to 2.6 as well. 2.6 feet, 2.6 inches, depends on what the one is. Right? So if that, whatever that angle comes out to in radians, this arc is going to come out to exactly the same number. They're going to match. But that only happens in a unit circle. Okay? Any question on that idea? So, size of the angle and the size of the arc are exactly the same in this special circle. So, my goal is to figure out how many radians in 360 degrees. How much of the circle is 360 degrees? How much? All of it. So, if we can figure out the size of the arc that goes all the way around the circle, it's going to be exactly the same as the angle that goes all the way around the circle, because they match. So all we have to do is figure out the size of the arc that goes all the way around, and then we know the size of the angle that goes all the way around. But the key is we're going to know it in radians, not degrees, and that's what we want. So we just have to figure out how big that thing is in green, and that's the answer. What is that thing that I drew in green? I mean, it's a circle, but it's the what of the circle? It's the circumference. So the circumference of the circle, circumference goes all the way around. Whatever that comes out to, that's exactly the same size as the angle that goes all the way around. They always come out equal in this kind of circle. So we need to know the formula for a circumference. What's the formula for circumference? Well, when you're dealing with a circle, what number is usually involved? Like circles, spheres, cylinders, they all have pi, so pi is in there somewhere. Anyone remember? Yes, yeah?
2 pi r squared.
So you kind of mix the area and the circumference all together, but you've got the right kind of pieces there. Anyone have another guess? But you're very close. You want to modify your guess at all? No? Anyone have another thought based on what Maddie just said?
Is it just pi r squared?
That's the area.
Oh.
Pi r squared. We need the circumference.
Pi r.
R, yes. The circumference is 2 pi r. So, there's your geometry. There's the circumference. Now, we're working with a very special circle. We already know something about it. It's a unit circle. What does that mean? Yeah.
You know the radius?
The radius. How big is the radius in a unit circle? 1. So the circumference is 2 pi times 1. Now that's the circumference. But more importantly, whatever we get when we do that out, that number is equal to the angle measured in radians. And that's what I want to know. That number is equal to the angle's measurement in radians. So, 2 pi times 1 is just 2 pi. That's the circumference of the circle. That's also how many radians it takes to go all the way around the circle. 2 pi radians. So now we know in 360 degrees, there are 2 pi radians. I don't know if you noticed, but sometimes when I drew angles on this, all of a sudden the number turned to a number with pi in it. Like right there. Does it again there. Does it at different different spots. Depends where you are. So if I go all the way around, you'll notice it says 360 degrees at the top, and it says 2 pi at the bottom. That's because there's 2 pi radians in 360 degrees. Any question on that? All right, so if, scroll back down. If in 360 degrees there's 2 pi radians, what could I divide each, and I'll put RAD for now. You gotta get used to not seeing RAD eventually, because they don't put RAD on the label, but I'll put it for now. What could I divide each side by, just to make the numbers a little smaller? Yeah, divide each side by 2. So if in a full circle there's 2 pi radians, how about in a half circle? Jacob?
1.
Well, in 360 there's 2 pi, so in half that there's
1.
1
pi.
1 pi, yeah. So pi. So in 180 degrees, that's 3.14 radians. Now, it's fine to have a conversion like that, but most of the time, you wouldn't give somebody a conversion with numbers like that. Shay, can you give me a conversion between anything and anything? Pick anything you want and just tell me how to, like, from one to the other. And this many whatevers, there's this many whatevers.
For a conversion?
Yeah,
like,
any conversion.
Like a half, or from...
Like actual units.
Oh, in units?
Yeah,
oh,
yeah. It could be length, it could be time, it could be...
Oh, there's inches and feet. Would it be inches and feet? Would that work? Or
Between what?
inches and feet?
Sure, yeah, give me the conversion between inches and feet.
Second to minutes.
Can you actually tell me how? Like if you said...
how? Like
Yeah.
inches and feet?
Yeah, how many inches in a foot?
Oh, there's 12 inches in a foot.
12 inches in how many feet?
Yeah, but 1
In 1 foot.
Yeah.
So he said 12 inches, 1 foot.
Yeah.
Okay. Can someone give me a different conversion? Yep.
There's 16 ounces in a pound.
There's 16 ounces in 1 pound. So both those conversions have something in common. Somebody give me one more conversion? Yeah.
60 seconds in 1 minute.
60 seconds in 1 minute. Her conversion also has the same thing in common as the other two. What do all those have in common? Yeah?
Pounds. Or the end is 1.
They all have a 1 in it. Usually when you give someone a conversion, nobody said to me like in 36 inches there's 3 feet. They simplified it and they just said 12 inches in a foot. Okay? So usually when you give someone a conversion, it has a 1 in it. If we change one of these sides to a 1, that's going to tell us how to convert between degrees and radians. Let's start by, let's get a 1 on the left. So if I wanted to turn this number into a 1, all I have to do is divide it by itself. And as long as I divide each side by the same number, my equation is still true, right? 180 equals pi, that was true. And I divided both sides by the same thing. Now I have 1 degree equals pi over 180 radians. This is the whole key right there. Now, let's say I wanted to know how many radians in 2 degrees. What could I multiply each side of this equation by so I could turn this side into a 2? Jillian? So I have a formula that says 1 degree equals, and I know what 1 degree equals. But what if I wanted it to say 2 degrees equals? What could I do on both sides?
Multiply by 2.
Yeah, if you multiply by 2, and again, just watch this because I'm going to erase that in a second, times 2. Now you've got a formula for 2 degrees. What if I wanted a formula for 6 degrees? What could I multiply both sides by? 6. Now the left says 6 degrees equals, and there's the answer. It's 6 pi over 180. So the key is, whatever you have, whatever you want to convert to, all you have to do is take that number you're trying to convert from degrees to radians, you multiply by pi, and you divide by 180. That never changes. Pi over 180 always stays the same. So to convert from a degree to a radian, first thing you do is multiply what you're trying to convert by pi. So if it's 6, multiply 6. If it's 2, multiply by 2. Multiply by pi, and then divide by 180. Okay, we're going to go through. We're going to go through some examples. But that's the key. Pi over 180. Multiply by pi, divide by 180. That converts you to radians. Okay, what we also want to be able to do is convert back. So let's take a look at how we could go the other way, from radians to degrees. I'm going to take the equation that I started with right there, and I said I want to get a 1. And you had a choice. We could have got a 1 on the left, or we could have got a 1 on the right. Let's copy it down. Where did I get a 1 before? On the left or on the right? I got it on the left. Okay. Now let's get a 1 on the right. How could I get a 1 on the right side? Yeah.
Divide pi.
Divide by pi. Divide by pi. Pi divided by pi is 1. The word radian is still there. Again, you kind of got to start thinking of RAD as being invisible because you're not really going to see it, but I'm putting it for now just to kind of help you. And 180 divided by pi. Now, look at what you've got here. Before you had pi over 180, now it's the opposite. It's 180 over pi. So if I wanted a formula to know for 5 radians, how many degrees is it? I could take this fact, just do a times 5 and a times 5. And now it says 5 radians equals, and I could do out the calculation. If I wanted a formula for 6 radians, times 6 times 6. Doesn't really matter what you're trying to convert. The key is whatever you want to convert, you're going to multiply it by 180, whatever you want to convert times 180, and then divide it by pi. So to convert from radians to degrees, multiply by 180, that's the first step, and then divide by pi. So the two steps, they're very similar, whether you're going from radians to degrees or the other way. One time you multiply by pi, one time you divide by pi. So it can be a little tricky to remember which way is which. Okay, I'm going to show you a very simple way to remember which way is which when we do a problem. The only thing you have to remember in order to know those two steps is when you think degrees, I want you to always think of the number 180. When you see degrees, think 180. When you see radians, think pi. Just remember those two things. Kind of connect the number 180 with degrees, connect the number pi with radians. And if you remember that, all these steps automatically fall into place, and you don't even need to remember these steps. Okay, so let's look at our first example, converting between back and forth between radians and degrees. All right, So the first problem we have is 60 degrees. Now, I know when I want to convert this to radians, I'm going to do one of two things. It's either pi over 180 or it's 180 over pi. Those are the only two options that we got. We just have to figure out which one to use. Now, 60 degrees, that's not a fraction. We could make it a fraction. What number could we put in the denominator of 60 to make it a fraction? 1. Just put a 1. Now, look at 60 degrees. You've got degrees in the top of the fraction. The goal is to end up with radians. So we want degrees to cancel out. In this fraction, where would degrees have to go to cancel out degrees that's already in the top? It would go in the bottom. So if degrees goes in the bottom, the other unit, radians, goes in the top. Now you just have to remember the two numbers. Okay. When you think degrees, what number did I say to always think of? Think of the 180. And when you think radians, pi. So we're multiplying by pi and dividing by 180. Degrees cancels. And how about 60 and 180? Are they both divisible by anything? Check. 3? They are divisible by 3. Any even bigger? Yeah.
60.
60. Yeah, we can go all the way to 60. 60 goes into itself once. 60 goes into 183 times. If you had divided them by 3, that's okay. You're just going to have to reduce them again. Questions on how we reduce them? Now multiply straight across. 1 times pi is how much? Pi over 1 times 3. 3. And there's your answer. Notice I didn't put the label RAD on it. You don't need to. Okay, you'll never see, I'm going to stop writing RAD for now because you're never going to see it. The only time you see a label is if they want degrees. They put the little circle. Right? So 60 degrees is pi over 3 radians. Let's check that one out. So here's 60 degrees, and it tells you down below that's pi over 3 radians. So why do some of them have a fraction with pi, and then why are some of them just a random decimal? Usually the ones that have a fraction with pi are ones that are multiples of 30 and 45. Most of the time. There's some other ones that this circle does, but if you pick another multiple of 30, like 120, notice that's another fraction with pi. Pick just a random number like 138, just a random decimal. So that's kind of the pattern when it has a fraction with pi. If they want you to round it off, they'll say in the directions. Otherwise, that's the final answer. You don't do anything else. Okay, let's try 150 degrees. Again, if you memorize whether it's pi over 180 or 180 over pi, that works. If you don't, think of where degrees would have to go to cancel out. Okay, so Carissa, in this one, still converting degrees to radians. Where would degrees go to cancel?
The bottom.
The bottom. That means radians is in the top. Pretend it says RAD. It's invisible. Okay, we're not going to write it. And Kylie, the number that we think of when we think degrees?
180.
180. And the number we think of with radians? Pi. Most of the time, you can always reduce. So if you can, do that first. What number goes into 150 and 180? I mean, there's a lot of numbers, but can you think of the biggest one?
30.
30. 30 goes into 150 how many times?
5.
180?
6.
6. There's your answer. 5 times pi with a 6 in the bottom. And that's 5 pi over 6 radians. How do I know it's not degrees? There's no little circle. So it has to be radians. Questions on that one? All right. Try one with a negative. Negative is pretty much the same thing. Only difference is when you're done, your final answer should have a negative in front of it. Okay, so take a second and see if you can convert that to radians on your own. Okay, and I'll put up, let's see. Yeah. I'll put up both of those at the same time. Negative 45 degrees and then 90 degrees. All right, so both of these are exactly the same type of problem we just did. So both of them we're going to multiply by pi, divide by 180. Degrees cancel, and what number goes into 45 and 180?
45.
45. It doesn't always happen that this number always goes into this number evenly, but it does happen a lot, and that's why we can reduce it. 1, and how many times does 45 go into 180? 4 times. So the answer here is negative 1 times pi over 4. As I went around, some people had the negative in the top, some people had it in the bottom. It doesn't really matter. I usually put negatives in the top, but if you put it in the bottom, that's okay. Okay, let's try this one. Times pi over 180. Degrees in the top, degrees in the bottom is gone. And what about number that goes into 90 and 180? 90. 1, 2. So you're left with 1 times pi with a 2 in the bottom. Pi over 2. Okay, so everyone we've done up until now, these are all what we call exact answers. We didn't round anything off. Okay? This one, 107 degrees. It's just a random number. It's not a multiple of 30. It's not a multiple of 45. So usually on a problem like that, they're going to tell us to round to 2 decimal places. So you do it exactly the same way. The only difference is, last step, type it all into your calculator. So I still want degrees in the bottom to cancel degrees in the top. And now we type it in. Okay. When you type it in, use the pi button. Okay. If you use 3.14, that's rounded off, so we'll stick with pi. 107 times pi, divide by 180. That's about 1.87 if we round to 2. 1.87 radians. Any questions on converting from degrees to radians? Okay, radians to degrees is pretty much the same. We just flip that fraction. So the first one, I put RAD just to label it. I'm going to erase it after that because you got to get used to not seeing it. Okay, pi over 6. I know it's in radians. So I've got radians in the top. I want to cancel it out. Where is radians going to go to cancel? Top or bottom? It's going to go in the bottom. Again, I'm going to write it this time. After this, I'm not. So radians in the bottom, degrees in the top. Okay, Alexandria, what's the number that we always think of when you think radians? Pi? Yep. And the number we think of when we think degrees? 180. And now, multiply straight across. It's easier if you cancel out anything that you can first. Is there anything there that cancels? Yeah.
6 and 180.
Okay, we can reduce 6. 6 goes into 180 how many times?
30.
30. Okay. Anything else I can do? The pi's cancel. Anything else? Still want to check?
The radian.
Yeah, the radians. We canceled out the unit. And that's the point. We wanted to end up with degrees. So let's look at what we're left with. Nothing here. All we're left with is 30 degrees divided by 1. Do I have to put divided by 1? No. Now, do I have to put the degree symbol? Yes. If I leave it like that, you just wrote 30 radians. Now you put 30 degrees. Any questions on that one? Let's try this one, and then I'll let you try one, and then we'll do one as a decimal, and then that'll be it. Okay, I'm going to erase this. All right, I know it's radians, right? There's no degree symbol. The direction set, change that to degrees. So in my head, I imagine RAD, it's invisible, and it's right next to pi, and it's in the top on the left. How about Jodelis? Did I say it right? Jodelis, sorry. Where's radians going to go?
The bottom.
It's going to go in the bottom. And the number you always think of with radians?
Pi.
Pi. So if pi goes in the bottom, 180 goes in the top. Okay. Radians, it's invisible. It's next to pi. Radians is gone. So RAD just canceled. What else cancels there?
Pi.
Yep, pi's is gone. And we can also reduce 2 into 180, 90 times. So 3 pi over 2 radians comes out to how many degrees? 270. 270. And sometimes what I do, once you start to get more familiar with degrees and radians, I knew that 90 is pi over 2. So that's one that I have memorized. 90 is pi over 2. Well, look at this number. Pi over 2. That's 90 tripled. That's all it is. So I recognize that pi over 2 is 90 times a 3. So in my head, I just think 90 times 3 right away. Right? Once you have some of them memorized, it makes it easier to figure out other ones. Okay, try that one on your own. Again, I'm going to get rid of that. And then we'll try one after with the calculator. Okay, so let's look at converting negative 3 pi over 4 to degrees. So honestly, the way I do this problem in my head, I don't know if we did pi over 4. Well, we did negative pi over 4. So I think in my head, pi over 4, 45 degrees. It's one that I have memorized. This is, oops. This is triple pi over 4, but with a negative in front. Okay. But if you don't think of it that way at first, that's fine. Let's just convert it and cancel out the units. So, Nicoletta, what do I multiply by to do that?
Multiply by 180.
Yep. And divide by pi. Now, remember, in my head, I said I think of it as 45 times 3. Watch what happens right here. Those cancel. And 4 goes into 180 how many times? 45. There's your 45 times 3 right there. With a negative in front. So that's negative how much?
135.
Negative 135. Questions on that? Okay, and last one we'll look at is round to 2 decimal places, and it's just 3. Okay, and the directions are the same as what's above. Convert from radians to degrees. So, same step. Multiply by 180, divide by pi. Okay, I'm going to type it in, and the first way I type it in, I'm going to use the pi button, which is it's the correct way. And then I'm going to do 3.14 and show you how much off the answer is. So we've got 3 times 180, which is 540. divided by pi. So it's 171.89, and that's degrees. So do I need the circle? Yeah, I need to put that. Now, let's type in the same thing, but let's do 3.14. So 540 divided by 3.14. I get 171.97. Let's see. That's kind of far off. It's not like you got 0.89 and 0.88. That's pretty close. But 88 versus 97, it's kind of far off. So make sure you use the pi button. Okay. Any questions on that? Right, so where we're going to use that tomorrow is both the formulas that we learn tomorrow are formulas that only work if you're in radians. So if they give you a problem and it's in degrees, this is the first step. Change to radians. Okay, so homework tonight is 36 through 68. Just even. They're not all just the evens. Okay, you've got just about 15 minutes. Okay, so please use the time to try to get started on it. If you get stuck, call me over, I'll help you out. If you need a calculator because you don't have one for some reason, let me know because you need a calculator on some of these problems. So I would do the calculator ones first if you don't have one at home.